We'll clean both sides with steel wool to clean it. The next step is to take the mass of it. After taking the mass, it was found to be 0.5 grams. The next step is to tear metal into small pieces. Then we add it to our 100 milliliter beaker. 10 milliliters of 4 moles of potassium hydroxide was measured with a graduated cylinder and added to our beaker that we will then place into this beaker that contains the aluminum. Heat the mixture for 15 through 20 minutes on our hot plate. The filter paper, I'll be using a paper plate shaped in a funnel with a hole in the bottom. Then I add my filter paper. We will pre-moisten the filter with water. Heating the aluminum will dissolve and produce hydrogen gas. When there is no more gas bubbles during the specified time, then the reaction is complete. And then this is a funnel up above, and then what we're going to do is simply pour this, and the bottom should be clear. Pouring it in, we have the potassium aluminum hydroxide on the bottom. We rinsed it 2 to 3 times with 2 to 3 milliliters of deionized water to make sure leftover, and we will throw out the filter paper. We're going to allow our filtrate to cool to room temperature. Next, we're going to add 10 milliliters of 6 moles of sulfuric acid gently and quickly. Adding the sulfuric acid, it will gently warm up and it will form a white gelatinous aluminum hydroxide. Next, we're going to put it on our hot plate until it is fully dissolved. After heating it up, it should dissolve kind of like this. And then what we're going to do next is put it in an ice bath. This is it in the ice bath, and also the thing that was formed from heating it up was aluminum sulfate. Alum crystals should form within 20 minutes. And while we're doing that, we're going to be setting up our ethanol/water mixture. We're going to need a 10 milliliter solution. Right now I already have 5 milliliters of water, and I'm going to add 5 milliliters also of ethanol to get our 50-50 solution. Then we're going to place this in our ice bath also. The ethanol solution will be used to like prep our filtration and everything. Alright, this is our Buchner funnel. I don't know if you could see it, but there's like holes on the bottom. And then it's like, like a little flat bowl shape. This is my best attempt at it. First, we're going to measure the mass of the filter paper, and then we're going to pre-moisten it with our ethanol solution. Alright, this is our filter that I put on top of our Buchner funnel. And then what we're going to do is going to prep it with our 50% ethanol, 50% water solution. Okay, and after it's pre-moistened, my charger is representing my hose, my vacuum hose. And the Buchner is sitting like right on top of it. And then we're going to take our alum crystals from our ice bath, and then we're going to gently pour it in. After doing so, we're going to let it dry. After drying, this is what it looks like. And then we're going to take the mass of the filter paper and the alum crystals on top. The mass of our aluminum, to begin with, was 0.5 grams. And then the mass of our filter paper, what we did for the Buchner vacuum thing, was 0.30 grams. And then the mass of the dry alum and filter paper at the end of everything was 9.09 grams. So the mass of our alum at the end of our experiment was 8.79 grams. Now we get to theoretical yield. So we put our starting aluminum right here, which was 0.5 grams. Then we ultimately end up dividing 0.5 grams by 26.98, which is the atomic mass of aluminum. In this portion of this equation, we will get 0.01853. And then simply this will eventually cancel out. So eventually, we will multiply this by 474.46 grams of alum, which is the atomic mass of alum. And then we'll eventually get our theoretical yield of 8.79 grams of alum. Now, to calculate percent yield, we'll simply get our theoretical yield on the bottom, and then on the top, we'll get our actual yield that we got from our experiment. So 8.79 grams times 100 divided by 8.79 grams, our percent yield of 100%, which means that we did a successful experiment.